All right, yesterday we talked about null hypothesis and alternative hypothesis. We said that the null hypothesis is that the population parameter is equal to the claimed value. In other words, if we've done an experiment, nothing has changed as a result of the treatment or whatever else we did as part of the experiment. Nothing changed from what we would expect to have happen without the treatment. Or if it's an observational study, we found exactly what we thought we were going to find. We found whatever someone had claimed we were going to find. So that's the null hypothesis. And we talked about rejecting the null hypothesis and accepting an alternative hypothesis. And today, we're going to talk about why we would reject the null hypothesis. And we're going to put some actual numbers on this so that there's a clear reason for us to reject the null hypothesis. All right, and the reason goes back to what we were talking about on Monday. Remember on Monday, we said that something is statistically significant if there's a low probability that it occurred by chance. In other words, if we see a difference between an expected value and an actual value, that difference is significant if there's a very low probability that it happened just randomly. An example of that was we said if we flipped a coin 100 times and got 48 heads, we said that it doesn't seem very significant because the expected value would be 50. If we flipped the coin 100 times, we would expect to get around 50. But we know that we may have a few more or a few fewer, and we're okay with that. We said that that's not statistically significant to have 48. That difference doesn't mean that something's wrong with our coin. And we said that something is statistically significant generally if the probability that difference that we saw occurred by coincidence was less than 0.05, or it's significant at the 0.01 level if there's a 1% chance or less that the difference was coincidental. And so we're going to apply that same thing to rejecting the null hypothesis or accepting the null hypothesis. We are going to reject the null hypothesis if our p-value, remember from Monday that the p-value is the probability that the difference that we see occurs by coincidence. If the p-value is less than 0.05, then by convention, we are generally going to reject the null hypothesis if our p is less than 0.05. All right, so let's apply this to our problems that we have today. And let me do number one with you, and then I will let you do the rest of these. All right, number one says, well, first of all, it says that the following exercises describe the results of a hypothesis test in terms of the probability of obtaining a particular sample. In each case, use the given context to formulate the null and alternative hypotheses. Then discuss whether the sample provides evidence for rejecting or not rejecting the null hypothesis. So we need to do a couple things. We need to come up with a null hypothesis and an alternative hypothesis. And then we need to decide whether or not there's evidence sufficient to reject the null hypothesis. All right, so number one says the owner of a car rental company claims that the mean annual mileage for the population of all cars in his fleet is more than 11,725 miles. A random sample of n equals 225 cars from his fleet have has a mean annual mileage of 12,000 miles. Assuming that the mean annual mileage for all cars in his fleet is 11,725 miles, the probability of selecting a random sample with a mean annual mileage of 12,000 miles or more is 0.01. All right, so let's start by talking about, by defining our null hypothesis and our alternative hypothesis. So the null hypothesis is going to be that the mean annual mileage for this fleet is equal to, let's not do two equal signs there. The null hypothesis is that the mean is equal to 11,725 miles. Now this car rental company owner is claiming that the mean annual mileage is actually higher than that. And so we went out and we looked at 225 cars in his fleet, and we found that that in that sample that we looked at, the annual mileage was 12,000. The mean annual mileage was 12,000. Our alternative hypothesis here is going to be that the mean is greater than 11,725. That's what this car company owner is claiming, that the mean is actually more than the national average of 11,725 miles. All right, so how do we decide whether or not to reject this null hypothesis? Well, we need to look at this last sentence. Assuming that the mean annual mileage for all cars in his fleet is 11,725 miles. So assuming that this null hypothesis is true, the probability of selecting a random sample with a mean annual mileage of 12,000 miles or more is 0.01. So there's just a 1% chance that this is true, but we just happen to have found 225 cars that have a mean annual mileage of 12,000 miles. So our p-value, in other words, is 0.01, which you can see is less than 0.05. So this p-value is low enough that we're going to go ahead and reject this null hypothesis. There's a very low, only 1% probability that this null hypothesis is true, and we just by coincidence got the results that we got of a mean annual mileage of 12,000 miles. So we're going to reject the null hypothesis. We're going to accept the alternative hypothesis that the mean annual mileage is actually higher. All right, so that's number one. You have 5 more to go. Good luck.